Middle and inner ear. External ear include auricular and external acoustic meatus. External edge of auricular, that is helix. Opposite and parallel to helix, that is anthelix. Here it is tragus, antitragus, and lobulus. External acoustic meatus has two parts. External part, that is cartilaginous part, because cartilage is here, and bony part inside of temporal bone. And external acoustic meatus, it's finished at the level of tympanic membrane. And what kind of glands which produced earwax we have in external acoustic meatus?
Sebaceous
Glands. In Latin, they are glandula ceruminosa. Glandula ceruminosa. And earwax, that is cerumen. That is protection from environment.
20 grams.
External acoustic meatus is not straight, and if we need to see tympanic membrane, it is necessary to move ear upward, backward, and laterally in adults, or we can move ear downward in children. Next, tympanic membrane. Tympanic membrane has fibrous tissue at the base, inside fibrous tissue. On external surface, it supplies with the skin, and inner surface supplies with mucous membrane. Most part of tympanic membrane has fibrous tissue, except small part in upper side of the tympanic membrane. Here, only skin and mucous membrane. Fibrous tissue here is absent, and this upper part of tympanic membrane has name pars flaccida. All another part of tympanic membrane where we have fibrous tissue inside, it has name pars tensa. In central part of tympanic membrane, we have umbilicus of tympanic membrane, umba membrana tympani, because yes, like umbilicus, that is because fibrous tissue here has circular direction. In peripheral part, it has radiate direction, and in central part, circular. That is why here we have umba membrana tympani, umbilicus of tympanic membrane. Next, middle ear. Middle ear. What is this model?
Temporal bone.
Yes, it is model of temporal bone. You can see this process is
Zygomatic.
styloid, mastoid, and external acoustic meatus, and here it is absent anterior wall of external acoustic meatus, and we can see tympanic membrane here, yes? And now we cut temporal bone, and this is
Squamous part.
we move this part of temporal bone, and we can see tympanic cavity, cavum tympani. Tympanic cavity has 6 walls. This wall is lateral wall. It forms with the help of tympanic membrane. That is why name of lateral wall is Parius membranaceus. Parius membranaceus, because membrane, tympanic membrane is laterally. Parius membranaceus, and above of this wall we can see epitympanic recess. Here we have 2 bones, head of malleus and body of incus. Here it is. Then opposite middle wall, that is Parius labyrinthicus, because medially from this wall we have labyrinths of the inner ear. Parius labyrinthicus, and this wall has 2 windows, oval and round. Round here it is absent, maybe here round window and oval window. oval window closed with the help of malleus. Sorry, malleus, I said. Of course, it is base of the stapes. Insert into oval window, and this base of the stapes fused with oval window with the help of syndesmosis between stapes and fenestra vestibuli. Oval window, that is fenestra vestibuli. And fenestra cochlea, round window, it closed with the help of secondary tympanic membrane, membrana tympani secundaria. Next wall, that is anterior wall. And in front from this anterior wall, we can see what? Internal carotid artery. And that is why anterior wall of tympanic cavity has name Paries caroticus. And anterior wall has opening of auditive tube, Eustachian tube, tuba auditiva. Here it is ostium tympanicum, tuba auditiva, and opposite opening in nasal part of pharynx, that is ostium pharyngeum, tuba auditiva. Pharyngeal and tympanic openings of auditive tube. And function of auditive tube, it's equalize pressure, atmospheric pressure with a pressure in middle ear.
Okay.
And above of auditive tube, we can see muscle, that is musculus, help me. Tensor tympani. Musculus tensor tympani. This muscle fused with manubrium of malleus, and malleus the same fused with tympanic membrane. Where is my tympanic membrane? Yes, here. This is tympanic membrane, and you can see that malleus fused with tympanic membrane, and musculus tensor tympani, it's attached to manubrium, and if this muscle contract, it moves malleus, and malleus moves tympanic membrane and tense. It's change tension of tympanic membrane. That is musculus tensor tympani. Firin. And which cranial nerve supplies musculus tensor tympani?
Musculus tensor tympani. Wait. Sixth.
Dear.
No.
Fifth. No, not fifth.
Fifth.
Can I?
Facial now.
I don't know you.
Fifth.
Which branch of the fifth nerve?
Okay.
Mandibular.
Mandibular.
Nerve
Yes.
mandibularis.
Nervus
Mandibularis of
mandibularis.
nerve
Nervus mandibularis supplies musculus tensor tympani.
tympani.
Next, that is anterior wall, Paries caroticus. Posterior wall. What is this process?
Mastoid
That is
process.
why posterior wall is Paries mastoidus, and this is pyramidal process, processus pyramidalis on posterior wall, and from this pyramidal process start another muscle which attached to posterior crus of stapes. That is why name of this muscle is
Musculus stapedius.
And dear, which cranial nerve supplies stapedius muscle?
Yeah.
Nervus
Nervus
stapedius.
stapedius.
It is facial canal, that is end of facial canal. And in time when facial canal passes not far from tympanic cavity, it gives nervus stapedius and supplies this muscle. And behind of this pyramidal process, we can see cavities, antrum mastoidum and cellula mastoidea. That is why sometime in time of inflammation of middle ear, this inflammation makes, it is possible to continue to inflammation of mastoid process, that is mastoiditis. It is necessary in this case to perforate mastoid process and moves pus from this mastoid process.
Yeah.
Well, superior wall, that is Paries tegmentalis, it is roof of tympanic cavity, tegment tympani, and inferior wall, it is opposite to jugular foramen, That is why it is Parius jugularis,
Jugularis.
jugular valve, Parius jugularis. And in middle ear, we have three bones, malleus, incus, and stapes.
stapes.
Malleus has head and manubrium. Incus has body, short and long crus. And long crus has processus lenticularis. And stapes consist of head, caput stapedis, two crus, anterior and posterior.
cruise.
Posterior crus more convex than anterior. Anterior more straight and posterior more convex because stapedius muscle attached to posterior crus of stapes and base of the stapes. I already said that base insert into fenestra vestibuli.
Oval window,
Oval window, yes.
Yeah.
And now, these three bones makes two joints. They are true joints with articular surfaces, articular capsule, and articular cavity. First joint, articulatio incudo mallealis, and second, articulatio incudo stapedius.
Stapedius.
That is middle ear. And now inner ear. Yes, we use this model. And we put
Three rings.
this is inner ear. It consists of bony part, bony labyrinth, and inside of bony this blue color, that is
Membranous
membranous
labyrinth.
labyrinth. Bony, first of all, bony part. Bony labyrinth consists of three parts. Anteriorly, that is what? Cochlea. Middle part here, that is vestibulum. And posteriorly, that is three semicircular canals.
Canals, yeah.
Canalis semicircularis anterior, posterior,
Posterior
and lateral.
Lateral. Okay.
You need to identify and answer in time of final exam, is it right or left labyrinth? How to do it? Cochlea should be anteriorly in front. This is right, yes, because this
Lateral.
canal should be lateral. If I take in my left hand, now it's look medial.
Medial, yeah.
And look here, on lateral side of the vestibule, oval and round windows.
Yeah.
Fenestra vestibule and fenestra cochlea. Both of them also should be laterally. This is correct position of labyrinth. And now we start to speak about cochlea and then vestibule and semicircular canals. Cochlea, it has in center it has modulus, that is not necessary to draw for you, only for your understanding. That is a bony stick, and cochlea surround one wave, second, and half. 2.5 waves of cochlea which is surround modulus. And now I draw cochlea like straight tube. This is cochlea, that is bony part, and inside of cochlea we have duct, ductus cochlearis, cochlear duct. And in histology, I think you draw
Yeah.
upper, that is ductus, here it is ductus cochlearis, cochlear duct. And that is canal of cochlea, wall of the body part. Above of ductus cochlearis, this is scala vestibuli, which is attached to fenestra vestibuli. And this fenestra vestibuli closed with the help of stapes, that is base of the stapes. Here it is. and scala tympani below of cochlear duct. Scala tympani, it finished at round window, fenestra cochlea, and it's closed with the help of secondary tympanic membrane. And if stapes insert into fenestra vestibuli, it moves perilymph, that is fluid, in this place. And you can see that ductus cochlearis is smaller than cochlea, and here we have communication between scala vestibuli and scala tympani. And in scala tympani, perilymph moves and moved secondary tympanic membrane into middle ear. That is, if stapes insert, in this case, secondary tympanic membrane is convex into middle ear. Then, with the help of elasticity of secondary tympanic membrane, it moves forward, and the perilymph moves in opposite direction. And all time, movement of perilymph here and here, it moves this and this membrane. Here it is, we have tectorial membrane, membrana tectoria, and this is basal membrane, and basal membrane has sensory cells of organ of Corti. They are hair cells, and these cells attach to tectorial membrane. And if fluid moves here and here, in this case, these cells and hairs of these cells attach to tectorial membrane, and impulses start and goes to first neuron. It is spiral ganglion spirale. It is in cochlea. And from spiral ganglion, axons through vestibulocochlear nerve, that is pars cochlearis, cochlear part, goes to
Medial geniculate body.
no.
Auditory.
Okay, inferior colliculus.
Oh yeah. Pons.
First of all, goes
Yeah,
to
pons
pons,
and then rhomboid fossa
and in
nucleus.
pons we have two nuclei, nucleus cochlearis
Cochlearis,
dorsalis and ventralis.
ventralis.
From dorsal nucleus, axons goes to the surface of pons and makes here stria
Medullaris,
ventricular
ventricular
quartzi, and from ventral cochlear nucleus, axons goes to opposite side through corpus
trapezoid body.
trapezoid body, and together these fibers makes loop, that is lemniscus
Lateralis.
Yes.
Yes, because it is
Less.
medial,
Lemniscus lateralis, this one. Number two, stria medullaris. Number one, stria medullaris. Number two,
Corpus
corpus trapezoidum.
trapezoidea.
Number three,
Lemniscus lateralis.
And some of these fibers finish in inferior colliculus, and another fibers finish in medial geniculate body.
Yeah.
And from medial geniculate body, axons goes through
Radiatio
radiatio
acustica
to
temporalis.
cortical center of
transversus.
auditory analyzer,
yeah.
gyrus temporalis
Temporalis
transversus.
transversus.
And from inferior colliculus, we have tractus
Stectospinalis.
tectospinalis, the same like in
Decussatio dorsalis tegmenti.
yes, decussatio dorsalis tegmenti goes to spinal cord and finish
Anterior funiculus and motor
It is anterior funiculus
Funiculus,
and
yeah.
motor nuclei in anterior horn, and from motor
Striated
nuclei,
muscles.
straight muscles. That is diagram of auditory analyzer. And now, who is it?
not in our class.
You, it is not your.
Oh yeah, it is mine.
Yeah. In vestibular analyzer, receptors present in semicircular canals and in vestibule. In vestibule, can you give me textbook, please? Textbook. Thank you. Yes. Okay. This is that is bony labyrinth, and inside here
Membranous labyrinth.
And this is diagram of membranous labyrinth. Look here. In cochlea, we already said that we have ductus cochlearis, that is cochlear duct. Then in vestibule, we have two structures, sacculus and utriculus. Sacculus has communication with cochlear duct with the help of ductus reuniens, that is short communicating duct, ductus reuniens. And utriculus, that is place where semicircular ducts opens, ductus semicircularis, anterior, posterior, and lateral. And these three ducts opens into utriculus. Between utriculus and sacculus, we have ductus utriculus saccularis. Here it is number 10, ductus utriculus saccularis. And this duct continues into ductus endolymphaticus and finish with saccus endolymphaticus. Endolymph, that is fluid which is inside of this labyrinth, membranous labyrinth. And now, each semicircular duct has the same like canal, has two crus. One crus always is ampular. This is crus ampullaria for anterior duct. This is ampular duct, ampular crus for lateral, and this one ampular crus for posterior. Three ampular crus we have. This is simple crus, crus simplex, and this one is common crus for anterior and posterior duct. This is crus communis. In ampular crus, everywhere, in these three ampular crus, we have crests, crista ampullaris. And crista ampullaris it is not necessary to draw, just for your understanding. This is crista ampullaris, here crest, crest, crest. Each crest has sensory cells, hair cells, and hairs of these cells, they are in endolymph, present in endolymph of these semicircular ducts. And if we move our head laterally or forward, backward, upward, and downward, in these cases, these hairs, they are change their location, they move in this side or this side, and this movement it's due to nervous impulses, and these impulses continues to vestibular ganglion, ganglion vestibularia on the floor of internal acoustic meatus. That is why where are receptors of vestibular analyzers? They are in crista ampullaris, and also receptors in utriculus and in sacculus. In both of these structures, we have macula of utriculus and macula of sacculus. These two macula, they are also places where we have receptors of vestibular analyzer. Crista ampullaris and macula of sacculus and utriculus. First neuron in vestibular ganglion, then vestibular cochlear nerve, and this nerve goes to pons. And in pons, we have four vestibular nuclei. Nuclei vestibularis.
Superior, inferior, medial, and lateral.
This and this. From superior vestibular nucleus, Lemniscus medialis goes to lateral nuclei of thalamus.
Thalamus.
And from here through internal capsule goes to brain cortex, and cortical center is
Temporalis, medius, and inferior.
very good. From inferior vestibular nucleus start tractus vestibular spinalis, and tractus vestibular spinalis goes to spinal cord and finish in motor nucleus.
Yeah,
Tractus
anterior.
vestibular spinalis goes to anterior horn and then continues to
muscles.
striated muscles.
Yeah.
The same vestibular nuclei has communication with cerebellum.
Cerebellum.
That is two-way connection. That is
Yeah,
fibra vestibula cerebellaris. And last, vestibular nuclei has communication with nuclei of cranial nerves. In midbrain, nucleus of third cranial nerve and fourth cranial nerve. In pons, it is nucleus of sixth cranial nerve and nucleus of 11th cranial nerve, nervus accessorius. And this bundle, which join together all of these nuclei, vestibular with motor nuclei of
nucleus.
third, fourth, sixth, and
And
11th, that I put here number 1, it is fasciculus longitudinalis medialis. Yes, if you remember,
Yes,
in
yes.
midbrain, we draw fasciculus
Longitudinalis
longitudinalis.
medialis, in pons upper.
the same.
Yeah.
And in medulla
Oblongata,
the
even,
same
yeah.
we have
Reticular formation.
this is
Yeah,
fasciculus
yeah.
longitudinalis.
Longitudinalis.
They join together
Bundles
cranial
of
nerves which moves eyes,
eyes.
and 11th nerve it supplies
head
sternocleidomastoid and
neck.
trapezius. It moves head and neck.
Neck, yeah.
And vestibular nuclei. That is why I can fix my eyes, move head, but my eyes continues to see this pen because muscles of the eye receive innervation receive information that head change position from inner ear, and they move eyes in corresponding direction together with coordination of muscles of the neck.
Neck, yeah.
That is fasciculus longitudinalis medialis, number 1. Number 2, tractus vestibular spinalis. 3,
Fibrocerebellar.
cerebella vestibularis and vestibula cerebellaris. And number 4, that is lemniscus medialis, lateral nuclei of thalamus, and brain cortex, that is virus temporalis medius and inferior. This is diagram of vestibular or statokinetic analyzer. Yes. Your questions? 2 diagrams, and you need to know these models and information about vestibular, about external, middle, and inner ear. Your questions?
Diagrams you have to do this or
This
follow
and
textbook ones?
yes, it is almost.
So we have to
I
draw.
think that it is almost the same. No.
It's somewhat like
Oh, that is cochlea, spiral ganglion,
yeah.
dorsal and ventral nucleus cochlearis. Here it is number 11 should be stria medullaris ventriculi quarti. Number 12 should be trapezoid body, corpus trapezoidum. This is inferior colliculus and medial geniculate body and brain cortex. That is the same like in my diagram. I draw here organ of Corti. No, only you put number 1 receptor in organ of Corti. That is all.
Okay, okay.
And here the same, not necessary, just receptors, increased ampullaris and macula of sacculus and utriculus.
Okay.
Not necessary to draw this crest, no, just receptor and that is all.
Okay.